trying to describe a typical value in a data set, you want to use a measure of center, either mean, median, or mode. We also talked about the shape of a distribution, right? It could be symmetric, it could be unimodal, meaning one peak, it could be bimodal, meaning two peaks. It could be multimodal, meaning three peaks. Trey, what does a uniform distribution look like? That's a bell shape. When it's
uniform straight line.
It's straight line. It means all values occur the same amount of times, right? And that was one of your homework problems. So now we're going to talk about something else, which is the other thing that describes an overall distribution is how much variability it has, meaning kind of how spread out it is, right? And again, just like there is for measures of center, there are going to be multiple measures of variation or measures of spread. So you can think of this as spread. I don't remember why I put a picture of Reese's Pieces there. I think probably just because it's my favorite candy and I couldn't think of anything to put there. She meant the technical term for them is a lentil, Shayna? A Reese's lentil. I like the Reese's lentils.
A Reese's.
What about the ones that have the Reese's Pieces in?
It's overkill. I've tried them. They're not. It's too much.
It sounds good.
Reese's Pieces are far superior to M&Ms, though. I will say that.
Yeah. Absolutely.
All right. So folks, this is a really short lesson, so we're going to move through it pretty quickly and we'll get some time today, but just make sure that you are staying with me, asking questions if you have them. So why variation matters. Consider the waiting time for 11 customers at 2 banks. We got Big Bank and we got Best Bank. And if we look at a histogram of their distributions, the middle of the histogram is technically representative of the mean. So while on average, it looks like the middle of this one's around 7.5, and I would say about the same for this. They tend to have the same average wait times, right? The same centers, about 7.5 minutes. Which bank would you want to go to, though, in terms of wait times? Best Bank. Big Bank has more variability. While on average the wait time is 7.5 minutes, sometimes it can be up to 11 minutes, right? Whereas Best Bank is much more consistent. It's pretty much always between 7 and 8.5 minutes, right? So there are less surprise wait times. So this is just one reason, one kind of anecdote about why variability might matter. All right, our first measure of variability or variation is the range. And you guys told me this. The range of the data set is just the high value, the max, minus the low value, the min. It's a pretty basic measure of spread. The problem with the range as a measure, oh, I'm sorry. Thank you, Naomi. Not sharing my screen. I'm recording. It's recorded. Don't worry. You guys can go back and catch those first 3 minutes. It was exciting. There was a slide with a picture of Reese's Pieces on it.
They were probably really confused the whole
About why I just randomly started talking about Reese's Pieces.
Yeah.
I don't think that's that out of character for me. Here's the problem with your range. Highly affected by outliers, which could not tell the true story. All right, who thinks they're the oldest student in here? Shayna? How old are you, 18? Who else is 18? Okay. When's your birthday, though, Shayna? Anybody earlier? Who thinks they're the youngest? Who are my juniors? Birthday? Oh, just barely beat you. So you're the youngest. And so you're 16? And so if we looked at the range in this classroom, the range is 22 years. Now, if I reported that that's the variability of ages in our classrooms, does that actually tell the true story of what the range is? Why doesn't it? I'm an outlier. I'm 38 years old, right? So there's only one of me, though. Truly, the range in the classroom is actually, the variation is pretty close together, right? Somewhere between 16 and 18 years. But that can be one drawback of using the range as a descriptor of how much variability there is in a set. It can get really impacted by outliers. All right, and this kind of illustrates that. Here's two sets of quiz scores. Which set has the greater range? And so range 1, the highest value is 10, the lowest value is 1, so 10 minus 1 is 9. Range 2, the highest value is 10, the lowest value is 2. And so the range there is 8. Which would you say is more varied, though, just looking at the raw data? Quiz 1 or quiz 2? And I'm not defining varied other than spread out or differing in values. Which quiz would you say it has more variation in score? 2, right? So you have a bunch of different scores in 2. 1, you have a bunch of the same and then just 1, but the range still comes out higher in 1 because there's an outlier. So again, this just illustrates that the range isn't always a trustworthy measure of variation. It doesn't always tell the whole story. So we're going to need some other measures of variation. All right, so one of these are quartiles. So here's how quartiles work. The first quartile divides the lowest fourth of the data set from the upper 3/4, meaning it's the median of the data set in the lower half. The middle quartile is called the median. It's the same as the median. And these have abbreviations that are accepted. Capital Q1 is understood to represent the lower quartile. The median we just tend to call capital M. And then the upper quartile or third quartile, Q3, divides the lower 3/4 of the data set from the upper fourth. And so it's the median of the upper half of the data set. So this isn't something that's particularly difficult to do by hand as long as the data set is small. But if it gets big, this can be pretty tedious. All right, so we have something called the 5-number summary for a data set. And the 5-number summary consists of your low value, meaning your minimum, your lower quartile, so Q1, your median, M, your upper quartile, Q3, and your high value or your max. And that divides up your data set into 25% chunks of data. 25% of the data will fall between any 2 consecutive versions of these, meaning like 25% of the data falls between the min and Q1, then an additional 25% between Q1 and the median, 25% between the median and Q3, and your final 25% between Q3 and the max. So a box plot, which I'm sure you've heard of, you probably heard it as a box and whisker plot. Maybe, maybe not. It's just a visual display of those 5 numbers. And the way we tend to draw it is you graph a horizontal axis that you'll label these on. And then above that horizontal axis, you're going to do a line at your lower quartile, a line at your median, and a line at your upper quartile. And you're going to connect those in a box. Like that. And then above your high value, you'll do a dot. Above your low value, you'll do a dot. And then you'll connect those with lines or whiskers. And so no matter what the size of each section, that section will contain 25% of the data. So this gives you an idea about how spread out or compact the data is within each quartile. All right, so let's do an example of a box plot, and I'm going to show you how you can get this in your calculator as well. Let's go back to this raw data with Big Bank and Best Bank. So this is important. Everybody needs to do this in your calculator while I do it. So make sure you have your calculator out. And what we're going to do is we're going to go stat edit. So we're going to pull up our lists. In list 1, let's put our Big Bank data, and in list 2, let's put our Best Bank data. So you're going to have to be able to do this on a test, so make sure you understand the functions in your calculator. So go stat, edit. If there's anything in list 1, just clear it out. All right. I'm going to freeze. Are there any left in there? Here. Here you go. So I'll freeze it for you guys there. I'm going to enter my data in my calculator real quick, and then we'll be back. Whoops. So list 1, we're going to go 4. Come on. All right. So when you're done, yours should look like mine. Is anybody having issues doing this or clearing out a list, or did you accidentally delete a list? I could tell you how to fix that. Any of that?
Does it matter what we're doing?
No, it doesn't really.
I'm still confused on how to get there.
Stat, you see the stat button?
Oh my gosh, yeah, I'm blind. Yeah.
And then hit enter on edit.
Okay.
Scroll all the way to the top of the name of the list until list 1 is highlighted. And then hit clear, and then scroll down. There you go. All right, I'll give you another minute.
There's another 6.7 in that column.
I did?
Yeah, so So that's why I asked.
Are you lying to me? Oh, I did miss it. Thank you. I rushed. Yeah. Is that the box and whisker looking one?
Yeah,
There's two.
box that has dots after it, but that next one is box.
All right. Is everybody good? You're going to want to choose the one with dots because that'll show you if there's outliers. Yep. Yeah. I just wanted to wait for everybody to get here. We're good. So we're going to go into stat plot, which is above y equals. So you're going to choose second y equals. And then just hit enter on the first one. Make sure it's highlighted on. So hit enter on on. And you'll notice there are two options that look like box plots. There's this one that has two dots by it, and then this one that's just a box plot. We're going to choose the one that has two dots by it. That, if there's any outliers, it'll graph the outliers as dots, and it'll just connect the lines to the next one that's not an outlier instead of treating the outlier as like the minimum or the maximum. All right. X list, I want list one for that one. The shortcut to list one, you can just do second one. You see the little L1 above that. Frequency should be 1. And then as always, be creative. You get to be yourself right here. Are you a dot kind of person? A plus, a smaller dot, an even smaller one.
There's so many options.
Hey, that's why math is always understood to be a creative science. All right, but we want what are called parallel box plots because we have two sets of data. We want to graph them along the same x-axis. So we're going to go back into stat plot. So second y equals. We're going to go to plot 2. And you're going to choose the same type of graph, but you're going to change your x list to list 2 for that one. And then everything else should be the same. All right, so we put what? Big bank's data into list 1 and best bank into list 2. So for me, big bank is going to show up as magenta and best bank is going to show up as green. So once you have that all set, we'll quit to the main screen, so second mode. And then I'm going to go to my zoom options, and I'm going to choose zoom stat. That's the 9th option. There we go. I got parallel box plots on the same axis. All right. Just based on intuition, do these look relatively symmetric or does one of them seem skewed? In which direction? If there is a skew, it would be so slight, right? But I would say they're both relatively symmetric. If there's a skew, I think we'll see a data set where the box plot has a skew. It'll be pretty obvious where one side stretches out way further than the other. Like one side's really compact and then the other stretches way out. Now, you can see your 5-number summary by hitting trace and then using the arrows. So this was big bank. So its min is 4.1. Its Q1 is 5.6, median 7.2, Q3 8.5, and max 11. And if I go down to the other one, it'll let me run through the 5-number summary as well. And so just from this visual, it's pretty clear which one has more variation, right? Big bank, the magenta one, much more variation than best bank, but they're both centered at almost the same place. They both almost have the exact same medians there. You can see them right on top of each other, right? All right, so when you graph these, the y, like, how far apart they are vertically. There is no y-axis. It doesn't matter. The only thing that matters is the x-axis. You can always do these into your calculator because I'm going to ask you to graph some box plots. But what I recommend is doing them in your calculator, copying them over, and then you're just going to scale your x-axis based off your 5-number summary here, right? So let me kind of show you what that looks like on paper. The only thing you need to do on your y-axis is clearly indicate what box plot represents what data. Oh, come on, catch up here. There we go. Sorry, the only thing you need to do on the y-axis is clearly indicate which box plot is indicative of which data set, right? The x-axis does have units, though. It needs to be labeled. This is wait time in minutes. I don't need the x-axis scaled out like this. All I would do is mark down what the 5-number summary is on the x-axis. Like that's 4.1, that's 5.6, that's 7.2, that's 8.5, and that's 11.0. And then I would do the same for the other data set, right? So these are going to be a little closer together, so you're going to have to be a little more careful, but this is 7.8. But even if, as long as you do it for one of the data sets, I at least have some sense of scale for the parallel box plot on top of it. Does that make sense? So I don't need like a million tick marks along your axis. I just need some sense of scale so I can get an idea of where everything is in terms of quartile, max, min, and median. Anybody struggling to get their box plots going or need help? Online, you guys okay? Take everybody's silence as a yes. Ah, thank you. Thank you. Missed the green checks. All right, another measure of spread is called standard deviation. So range is a way to measure spread, but as we can see, range can be highly affected by outliers and sometimes may not tell the whole story of what's going on. Standard deviation. The formula is kind of complicated. Don't really need you to know it because I'm not going to make you do it by hand. But you're going to have to be fluent using your calculator, and you're also going to have to understand how to interpret it. The way you interpret standard deviation is typical deviation, which really just means distance from the mean. That's all standard deviation tells you. How far, on average, is any given piece of data from the mean? The more spread out a data set is, the higher that value will be. The more compact a data set is, the lower that value would be. With that in mind, what would a standard deviation of 0 mean? If the standard deviation is the average distance from the mean, and I told you that the standard deviation is 0, what do you know about the data set? How far is the average data from the mean? You guys have your AirPods in? Aiden,
What?
take your earbuds out.
Okay.
If the standard deviation is 0, and I said that the typical deviation it's the typical deviation from the mean, how far is the average data value from the mean? It means there's no variation. That's exactly right. The only way this can possibly happen is if you have a data set where every data value is the exact same. Does that make sense? So a standard deviation of 0 means all data is equal or the same. All right. Here are the steps to calculating the standard deviation. I used to make, the first 2 years I introduced this course, I made them calculate the standard deviation by hand. There's no reason to do that. So we're going to skip this slide, and I'm just going to show you how to compute it in your calculator, okay? All I need you to be able to do is calculate it and then interpret what that value means. You will need to know the standard deviation rule of thumb. So I do want you to write down these formulas, which is approximately the standard deviation is the range divided by 4. This is actually only true for certain data sets, but I just want you to write it down because on like the open note quiz, they'll go, here's the range. What's the approximate standard deviation? Which means that you need to use this specific formula. And then from that, you can approximate the max and the min. The min will be your mean minus 2 times the standard deviation, and the max will approximately be the mean plus 2 standard deviations. Setting me up during class here. All right, we good with those formulas?
Yes.
Oh, thanks. Before we do this, we're going to use the rule of thumb, but before we do that, let's go back to Big Bank and Best Bank, since we already have that data in our calculator. And you might want to make notes on this. I'm going to show you again how you can find the standard deviation. So for Big Bank, let's go to our calculator. I'm going to quit to the main screen. And we're just going to do this. Stat. We're going to go to calc, and we're going to calculate one variable statistics. What I'm going to tell is list one. If you have an older calculator, it doesn't give you this menu, and I'll show you what to do. It'll actually just show up like this. You're going to do one variable stats and then just say list one. You're just telling it what list I want you to run the statistical analysis on. List one is our big bank data. If I hit enter, it outputs all this stuff. We've done this before. X bar is the average wait time, right? That's 7.2 minutes. What does sigma mean again? Add up. That's the value if we added up all the data. Why do you need that? You don't. Sigma x squared is if I squared each piece of data and added it up. You don't need that. Sx, there's your standard deviation right there. So your standard deviation is Sx. Standard deviation has same units as your data. So this is 1.96 minutes. So if I were going to interpret that, I would say that the average person will deviate by about 1.96 minutes from the mean. Meaning, the mean wait time, as we saw, was 7.2 minutes. But that doesn't mean that everybody's going to wait exactly 7.2 minutes, right? There's going to be variability. So the average person may be 1.96 above that or 1.96 below that. Does that make sense? It's typical deviation from the mean. All right, let's do best bank. We're going to do the same thing. You're going to go stat calc, one variable stats, except you're going to change it to list 2. If you have an older calculator and it doesn't give you that menu, you're still going to go stat calc, one variable stats, but then you're just going to put list 2 right after that. The shortcut is right there, L2. So second 2. Hit enter. What's the standard deviation there? .445. What units? Minutes. Same as your data. So we would say, in this case, the average person will deviate from the mean by about 0.445 minutes. The smaller the standard deviation, the less variability, right? We said a standard deviation of 0 means what about the data set? There is no variation, meaning every data value is the exact same. So the lower the standard deviation, the more compact the data set is. The bigger the standard deviation, the more spread out the data set is, right? Does everybody feel comfortable with how to use their calculator to compute that? Because you have to use your calculator since I'm not showing you the hand computation. All right, last one is just how do we use that estimating the rule of thumb for standard deviation. Studies of gas mileage of a Prius under varying driving conditions show that it gets a mean. So I'm gonna notate this. X bar equals 45 miles per gallon with a standard deviation. So S sub X equals 4 miles per gallon. Estimate the minimum and maximum gas mileage that you can expect under ordinary driving conditions. And so from the previous page, we know that the min is about equal to the mean minus 2 times the standard deviation, and the max is approximately equal to the mean plus 2 times the standard deviation. So this isn't too crazy, but the min is approximately 45 minus 2 times 4, right? Well, 45 minus 8 is going to be 37 miles per gallon. And then the max is approximately equal to the mean, 45, plus 2 times that standard deviation. So 45 plus 8 will be 53 miles per gallon. And that is it. So you got a problem set, couple things. You got a problem set and you've got an open note quiz. I would start with the open note quiz as usual is my advice so that you don't forget to do it because you guys are losing a lot of points by not doing that. And then I would move on to the problem set. These aren't too long. I'm here to answer questions if you have them. Juniors, I would like to speak with you guys at my desk in a moment. I'll call you over. You guys can log off and work asynchronously if you like, you online folk, but Prescott, again, I need you to stick around for a minute.